Good morning, all of you present here. I welcome you for this presentation on dependency diagrams and normal forms. Going through the slides here. First, you're going to learn about what is data dependency, that is, how to draw a data dependency diagram. Actually, a primary key is very important in terms of a data table. Okay, every table should have a primary key, and then there are three types of dependencies. One is called as total or full dependency, and the other one is a partial dependency, and the third one is transitive dependency. We are going to learn about the first one, which is called as total or full dependency. Actually, what happens in total dependency means one non-key column dependent on all primary key columns shows total dependency. For example, all the other attributes will be dependent on one attribute, one that is one non-key column. That is actually called as full dependency. For example, I'll be telling about employee number. Employee number is the primary key, and all the other attributes, that is employee name, employee mobile number, employee date of joining, everything will be dependent on the primary key, that is the employee number. So this non-key column, you're going to call it as exhibits a full dependency. The other one is a partial dependency. Partial dependency is actually a non-key column is dependent on part of a primary key. Then it is called as a partial dependency. For example, employee number is a non-key and is dependent on any one of the primary key. Okay, suppose you're having two primary keys and one part will be dependent on the other, then it is called as partial dependency. The other one is transitive dependency. Transitive dependency, one non-key column which is not a primary key, which is some other key, is dependent on some other non-key column, then you're going to call it as transitive dependency. These are the main things that you're going to know when you're going to draw a data dependency diagram. Okay, first you're going to go through this diagram here. Actually, when you're going to draw a dependency diagram, the top part is actually the arrow mark, which is going from top to bottom, that is downward arrow mark, indicates full dependency. All the partial and the transitive dependency will be drawn on the bottom half of the dependency diagram. Here in this, we are going to see about employee project database, and you are having what is called as a project number. Project number will be there, project name, and then employee number, employee name, and department number, department name, and hours of work. This is actually about employee project database. Actually, we are having the project number and employee number. These two are there. What you are using is a composite primary key here. That is, the project number will be having its own dependency, and employee number will be having its own dependency. So a dependency diagram illustrates the various dependencies that may exist in a non-normalized table. Okay, actually we are having employee number, employee, that is a project number. You're going to combine both, that is employee number and project number are combined to become one primary key, that is composite primary key. So here what happens here is project number is one of the primary key. There is one non-key column which is dependent on prime, that is project number. Project name is dependent on project number, so it exhibits what is called as partial dependency. What is partial dependency means? Only one of the primary key is dependent, whereas the other primary key is not dependent, so it shows partial dependency. Employee number, on the other hand, uh, it is another primary key. Employee name, then department number, and hours of work, all the columns are dependent on employee number, but it is that the project name is not dependent on employee number. So this also exhibits partial dependency. It's not exhibiting full dependency, whereas it is exhibiting partial dependency. So the other one is actually a Transitive dependency. Transitive dependency is one non-key column is dependent on another non-key column, then you're going to call it as transitive dependency, okay, which is depicted in this diagram. Then normalization. Normalization is a branch of relational theory, and this goals of normalization means the level of redundancy, the data which comes again and again will be uh, again and again will be eliminated. Okay, the process that it provides the mechanism of transforming schemas to remove redundancy. There are normal forms, that is first normal form, second normal form, third normal form, and BCNF. Okay, all these normal forms are used in normalization to avoid duplication of data which is there in the table. Okay, that is duplicates will be removed when you're going, that is redundancy will be removed when you're going for normal forms. The higher the normal form, the more the data will get, the table will get normalized. The first normal form, what happens here is that only single value attributes are permitted, multi-value attributes are not permitted. One particular column will be having multi-valued attributes, those are not permitted, only single valued attributes are permitted. For example, the primary key of a new relation is a combination of the primary key of the original relation plus the attribute of the newly created relation for a unique identification. Actually, it should have a primary key and it should not have any multi-valued attributes. If these two constraints are being satisfied, then it is the table is in relation with the first normal form. It satisfies the first normal form. Okay, for example, they have given us a school database here, and the process of this, you're taking one example here, and it should have a primary key and for the new table, and no multi-valued attributes should be there. That is given in an example. This, for example, here it is a student, there is a school database. You'll be having a student grade report is actually the database here. The student number will be there, student name will be there, major, course number, course name, instructor number, instructor name, instructor location, and grade. That you're going to first you're going to create a primary key, and then you're going to remove all the multi-valued attributes so that it becomes a single valued attributes. This is what is happening in the process of 1NF. Second normal form. Second normal form, it should satisfy the first normal form. The relation is automatically in second normal form, and what happens means single valued attributes should be there. And the other thing is, if the relation has a composite primary key, and then each non-key column must be fully dependent on either the primary key or the subset of the primary key. Everything should be dependent on the primary key and the subset of the primary key. Then it is called as 2NF. It satisfies 2NF. So what happens here is you have to identify the primary key, and it should be a single column, and then what happens means it's a combination of primary keys should be combination of primary keys should have the total control over that particular database. Okay. So what happens means that the third one is a third normal form. You have to remove the transitive dependency. One non-key column will be dependent on another non-key column. Then you're going to call this a transitive dependency. You have to split the table so that you can remove the transitive dependency. All transitive dependency should be removed, and then you are going to create a new table so that you're going to split the table so that transitive dependencies are removed. This is what is happening. You're going to split a new table, you're going to create a new table, and you're going to add it there. Okay, then Boyce code normal form. BCNF, when a table has more than one candidate key, anomalies may result even though the relation is in 3NF. That is a third normal form. Boyce code normal form is a special case. It is actually what happens means it for every determinant there is a candidate key. So you'll be having as there are different anomalies are there, that is called as the insertion anomaly, updation anomaly, and deletion anomaly. Insertion anomaly means when you're going to insert one particular data into a database. Suppose you cannot allow a particular field as empty, then it is called as insertion anomaly. You have to enter, but the data won't be there. That is called as insertion anomaly. Updation anomaly means, suppose if you want to update one particular name it reflects in other changes also. Then it is called as updation anomaly. Suppose if you delete one particular customer name, then what happens, the other fields which are required will also get deleted. This is actually called as deletion anomaly. Anomaly, you're going to reduce the relation based on BCNF, based so that it becomes a no single value attribute is a candidate key here in BCNF. Okay, and then that is called as functional dependency 1, functional dependency 2, functional dependency 3, and functional dependency 4. In functional dependency 1, what happens here is client number, interview date, and you're having room number as the primary key. Functional dependency 2, client number is the composite key, and functional dependency 3, staff number and client number is the composite key, and functional dependency 4, actually you'll not be having any key here. That is actually one, it is a table that you have created. Okay, then the normalization and database design. One, you're going to design a database. It should be normalized so that many real world databases have been designed improperly, so that once you modify everything, it will take lots of time and effort. And the normalization procedure focuses on characteristics of specific entities and is represented in micro view of the entities with within the this entity relationship diagram. It is difficult to separate normalization process from entity relationship modeling process. The two techniques should be used concurrently at the same time. Okay, with this we are winding up the concept of data dependency and normalization. Thank you.